Okay, let's look at some application problems. Most people find these fun, although I'm sure at this point you guys are probably thinking, why is she using the word fun? You've worked so hard to get to this point. Whenever you have a situation involving a right triangle, such as you do here, you certainly want to look for angles and known sides, and then you can make right triangle relationships to solve triangles. The problem here is from a point 20.3 meters above level ground, an observer measures an angle of depression of an object on the ground as 56 degrees. Determine the distance d in meters from the object to the point on the ground directly below the observer. And you are allowed to use symbolic entry. So for example, instead of, if you want to type sine of 30 degrees, you can use the degree symbol, or you could do the DEG notation that you've become accustomed to using. Let me make a couple of observations here. One is angle of depression. Whenever you're referring to an angle of depression, you have a point and you have a horizontal. So you can see the red line is horizontal, parallel to the ground, and you measure down to a line of sight. Okay, so the angle of depression in the picture is 56 degrees. Now, several ways you could look at this. You could look at the complementary angle here, or you could look at alternate interior angles and say that the base angle is 56 degrees. Okay, so if you use the complement over here, you would have had 34 degrees. Okay, so you can use either the 34-degree angle or the 56-degree angle along with the vertical height 20.3 and the base d. So you want to find d. I will just use the 34-degree angle, and I will say tangent of 34 degrees is the side opposite 34 degrees, which is D, divided by the side adjacent 34 degrees, which is 20.3. And since we are allowing symbolic entry, you can actually just put this right into the box and be done. So the calculation is 20.3 times tangent of 34 degrees, and that's in meters because the 20.3 was in meters.